Shall we hear now from some of the panelists who we haven't heard from yet, and then it's over to you. The last 20 minutes is over to you. This is all about radical innovation. What's on your mind? Since we've heard so much from the queen of storage, I'm so sorry about this name, a golden crown now, Christina Edström. So game-changing research, game-changing breakthroughs in storage. Are they going to happen? When are they going to happen? Tell us your thoughts.
Well, I hope it will happen because there are really intense efforts in European Commission at the moment. I don't know if you know that the Vice President Šefčovič launched the Battery Alliance, European Battery Alliance in October last year, and there will be a lot of more money put into really trying to promote disruptive research. And you can ask, what is disruptive research when it comes to storage? Well, of course, the transportation sector is extremely important, and we have heard about that. And that means that we have to make the batteries small but very powerful, and both in terms of energy density and power. And we may need to make them reliable and secure. They shouldn't fire up in our cars. And we need to make them with long cycle life because it's a costly component in the car. We have talked about that already. If you then want to scale up the batteries that you have in the cars today for large-scale storage, it might be so that the materials we choose for batteries for transportation are not the same as we choose for batteries for large-scale storage. And we have to remember that today, battery storage for wind and solar is quite small. It's about 0.5%, 99% is pumped hydro. So we have a little bit to work on there. And today the batteries for transportation is based on lithium. And you can probably make these lithium batteries with a double capacity compared to today. You can make them more reliable. You can make them perhaps more intelligent, going into the digital area with better control and with sensors, printable electronics, and then also being able to control the energy storage when you have your drone up in the air. But it might be so that the materials we have for the lithium batteries, we have to save them for the cars, for the transportation, and use other batteries, which might be lighter, even more energy dense. There are suggestions for that. There are ideas, but we are not really there yet. And that's where we have to fly out and be disruptive. If you look at the...
Why has it taken so long?
Pardon?
Why has it taken so long? So this is a very kind of no-knowledge question. But why has it taken so long for the promise to be delivered?
I think it's because it's the chemistry which decides. You really have to work on the chemistry. And it's so small, subtle, complex reactions that might damage your battery long term. And you need to be able to control that within the battery cell. And then when you're putting several cells together, you have to also to balance that. And that is actually taking a long time. But for me, who is a lot older than you, I think it has been a fantastic revolution. When this lithium battery came around, really, it was started to be commercialized in 1990, but when it came in full swing around year 2000, it has changed our behavior. We are always connected, and we are always with our laptops and our phones and so on. So for me, that has been a quick revolution. And now we are coming into the vehicles. And of course, the requirements for a battery in a vehicle is much tougher than the one in a laptop or a car or a mobile phone. The mobile phone batteries are quite lousy compared to the batteries in a car, because I know you will have a new, smarter phone 3 years from now anyway, so you don't have to optimize the battery in particular.
So the kind of predictions that are being made about EVs,
yes,
really soaring to quite high levels, and we heard lots of predictions this morning. Will the battery technology be there to support that?
I hope so, yes. In fact, in many ways, I think it's already there. It's a matter of cost, and it's a matter of public acceptance. Most people, they don't use the car more than perhaps 15 minutes per day, as it is today. So we can do it with what we have, to be honest.
If at all. Okay, so
If we have a bit money.
she's an
What we want to do in Europe, though, is to have our own production, because now everything is produced in Asia. And if we don't have our own production, we might lose other industries because of the battery. The automotive industry is strong in Europe, for instance.
Absolutely, moving fast to China.
Yes.
Alexander Breckier, so what do you see as really radical innovation? What are you looking to invest in? What are you looking to research? What have we not spoken about today?
Well, I don't know what you've all been speaking about today because I came late, but I can tell you that we work on all these and many, many other solutions. The battery questions is very interesting. It's also very interesting whether we want to dig into importing lithium and cobalt from strange countries in the world, or whether we want to drive our electric cars on hydrogen, for example, in the future, especially heavy vehicles. I think we work a lot on radical changes in food, climate-friendly foods, such as aquaculture and totally different industrial fertilizer with close to zero emissions. But when I challenge some of my, I'm not a scientist, so I challenge some of my really radical colleagues, they talked about, well, we do a lot on embedded inductive, wireless power supply. With ferries, with Wärtsilä, we've done this project where the ferry comes in and it doesn't connect, it just charges wirelessly. And if you want to be radical, I suppose you don't need to have a cord up to a flying wind turbine. You can just have someone put solar cells in orbit and you can wirelessly ground that electricity. This is crazy. I usually work with customers on a day-to-day basis, but I find that to be radical.
Okay, yes, I agree. This is radical.
Well, we have people working on superconductivity at so-called high temperatures, 150 Kelvin and above, which means transporting energy at close to zero resistance. That means that you can harvest the energy, the solar energy in Africa and transport it with zero loss or close to zero loss to the places where you want to use it. Thermoelectric new materials, where you can produce electricity directly from heat. For example, all the heat that's wasted on an oil rig or a ship or a car, you can immediately produce electricity. I'm just sampling here a little bit.
So these are 3 ideas you've come up with, right? They're all a bit kind of out there.
Yeah, and they're
all in the sort of slightly...
They're all scientific, but since I'm a lawyer, I want to bring on you asked for different kinds of radical thinking, and of course, the way we operate and govern our energy system can be innovated. And today, each country is suboptimally trying
Can you hold that idea about systems,
sure.
Alexandra, because we should have a discussion on that a little later. We've talked so much about technology. So hold that idea. But the 3 sort of technological, slightly crazy ideas you came up with, sorry to be blunt
We
about
don't
it.
all work on crazy things.
I know, I asked you to. But so are we going... What's the time horizon, do you think, that we might be talking about? Is this our grandchildren? Is it our lifetime? What is it? How realistic?
I think you will see signs of it, like thermoelectricity. We're starting to have industrial projects looking at.
Okay.
Scaling it up radically is taking a long time, but it is, you can create a disruptive spread of that technology within, let me guess, 10, 15 years?
Okay. So this is like watch that space. Thank you very much for now. Benjamin has been sitting very patiently at the end of the row, and I'm going to ask you a backward-looking question, if you don't mind, to help us look forwards. So we were hearing about hindsight, weren't we, earlier this afternoon? And my backward-looking question is, if we look back 10 or 15 years at what are now quite conventional technologies, solar and wind, yes, but were not necessarily, they were probably in this kind of Alexander category of some of the things she's been mentioning here, right? What can we learn about the successful transition of what were once radical ideas into successful ideas to help us going forwards? Does that make sense as a question?
Sure, why not? Thank you. I'm the director of a center on innovation, actually. It's called the Center on Innovation and Energy Demand. And it's always exciting to be on panels like this where we keep talking about all these high-tech things. But I think what I'd like to talk about, I'd like to make just 3 very brief points, also looking backwards.
Okay.
And I think the first of them is that we keep focusing on these high-tech, state-of-the-art automated systems. But often, many of the most significant gains we've made in decarbonization, changes in practices, are with very simple, mundane technologies. And so I think the best single example that I know of is energy efficiency. If you go back to 1970, and you look at the data the International Energy Agency has for the OECD, the single biggest source of energy since then has been efficiency improvements. Bigger than oil, bigger than gas, especially bigger than nuclear, renewables, and hydro. And that's very simple things like light bulbs, windows, insulation. You could save more oil than exists in the Arctic National Wildlife Refuge if people just inflated their tires in the United States, or if they stopped idling their vehicles. So these very simple changes in behavior, especially when they're energy efficiency related, can really capture large savings in cost, energy reductions, and carbon. I think the second critical point is that the discussion today has really focused on a lot of high-tech stuff that we are using in the north, literally the north, because we're in Norway. But there are also very simple technologies that can also save a lot of life and also cut emissions of things like black aerosols and carbon and methane. And I'm talking about cook stoves. So amazingly, if there are 4 million deaths a year related to how women and children cook, and large amounts of soot that get transplanted to the Arctic polar regions and Antarctic regions that accelerate climate change. And yet, you have immense success in diffusing improved cook stoves. I'm thinking here of the Chinese national program, which affected almost 900 million people in a matter of 20 years, with technologies that only cost about $10. Right, so again, I think it's important to focus on the high tech, but it's also important to think about the ordinary, mundane household technologies and to learn from some of the experiences we've had with them. And then my final point is just, I keep being reminded, it's like deja vu all over again, which is what Yogi Berra once said, these discussions about technologies. I was reading reports in the 70s from, I think, was it the ERDA, the precursor to the DOE? And it's the same thing they're talking about. High-tech microwave solar, high-altitude wind turbines, electric vehicles, et cetera. And I'm reminded here about a very influential paper that was written in Science more than a decade ago by Pakala and Sokolow, where they argued we basically have all the technology we need then, 12 years ago, to fight climate change. Hydrogen fuel cells, plug-in vehicles, better agricultural methods in food growing, energy efficiency, wind, solar, et cetera. The problem is not a problem of technology and innovation. It's a problem of politics, and it's a problem of values, and it's a problem of society. And so I think while the techno-economic fix is important, if we don't grapple with those other issues, if we've had the technologies to mitigate decades ago, why are we still here? And I think that suggests the most radical innovations we need are over our own behavior, not just technology.
So a voice of realism, and we got a whoop in the audience to that, Benjamin. So we've bombarded you with all sorts of ideas, ladies and gentlemen, boys and girls, disparate ideas. This is your chance now to explore them, anything that's on your mind, however eccentric it might seem. Steve Gabriel from NTNU has the first question.
Thank you for the last speaker. I was thinking for about a half an hour, roughly what you were saying. I just wanted to articulate a little bit more. So we have the technology, we have the economics. What is needed beyond that? And I think education. We haven't talked at all about education except for this last 10 minutes or so. So let me give you an example. In the U.S., cigarette smoking was not eliminated, but was mitigated to some extent by making it really negative through, public awareness, taking away advertising and things like that. Why couldn't we do the same for climate change at a very early age, like elementary school or something, where it just becomes the new default that you're immediately aware of all these climate change things. It's not even a debate. It's just, this is what the children learn. And I'm, on another area, I'm sort of reminded almost every day by my two 20-year-old kids about eating meat and not being vegan. Mm-hmm. And it's because they were, they got this at an early age. And so the educational innovation, I think, is extremely important, and it goes hand in hand with the technological and the economic aspects, and maybe someone can comment on that. Thank you.
So can I put that to the panelists then, that point from Steve, that actually, and Benjamin, that the most radical, most revolutionary things would just be us behaving differently? us, human beings, rich and poor, in the developed and developing parts of the world. Ellen?
Well, certainly behavioral change and social acceptance for dealing with climate change are incredibly important. But I think we should be a little careful before we say that every technology we need is already there, because many of the technologies we need, even 5 years ago, lithium batteries were much more expensive than they are today. We're seeing a great decrease in the costs. And we also have to pay attention to the fact that we have a huge fraction of the world which doesn't have adequate access to power and electricity. They need to have their standards of life increase, and to say that we should move forward with the expensive technologies that we have now is very difficult if we also want to bring billions of people up to middle-class standards of life. So I'd be careful with that.
Anyone else want to chew on that? Alexandra?
I just want to tag on to that, because in the biggest thing that happened to the women in Sub-Saharan Africa is the opportunity of solar energy, I think. And it's not further back than 2005, when I was working in Norsk Hydro, proposing we go into solar. All the world's greatest expert, Ernst & Young and everybody, told me that is the Gucci renewable, only fit for decorating yourself to look good at parties, right? And within just 10 years, it's become the solution for the poor world. So I think we're on the same team.
It's good.
So the lesson from that is that,
It's hard to imagine the cost decline.
yeah,
Before
I
it
mean,
starts.
if 2005, so 18 years ago,
Was 13 years ago.
13 years ago, sorry, solar was considered to be, what did you say, the
Well,
good?
they called it the Gucci renewable, something that you just put on to look good at events and conventions, and not something that had any practical application.
So what's the Gucci renewable of today that in 10, 13, 15 years' time we will look back and think, well, it was
In a way, the
obvious, it was
electric
staring us in the face.
Absolutely.
What is it?
Tesla.
Tesla, not going to Mars, but...
Well,
Well, Aidan.
Well, I get a bit back to the Stephen's idea that if you look at the UK, for example, there's huge they call it energy poverty. And a lot of that is because the people do not know how to simply insulate. Insulation doesn't cost that much. You need to know how to put it in. And I think there's a genuine ignorance of all things energy. So I think that's the really low-hanging fruit, is to help people. Or even say, okay, you just use one room of your house during the winter because that you can afford, and you make it, this sort of interactive, rather than these high-tech, solutions that we talk about. I think that would make a huge impact in the UK.
Okay.
And
So
then
we
I just
look back on how we live at the moment and think, my gosh, they were in the Stone Age, for imagining they could live in the whole house, and imagining that they could have curtains rather than those. What was that girl's idea about the solar sheet screens or whatever it is?
But you also have the huge question of affordability. So I mean, everybody would love a Tesla, but who can afford it? Even these curtains. To make a big impact, it has to be so incredibly cheap. Yeah. And that you could also say that you almost need governments to drive it.
We haven't spoken a great deal about governments today. Possibly because there's a disenchantment or realism about what can be delivered. And we haven't got many policymakers with us today. But what would we think would be a radical step for governments to do, looking into the future then? Benjamin.
I just want to redefine the question initially to say that it doesn't have to only be governments. One of the big things that's pushing solar in sub-Saharan Africa is new business models like pay-as-you-go or the bundling of services. So I think let's not exclude other actors like industry and the private sector. But to give you a quick answer, we also did a study, God, it's getting old now, about 10 years old, asking a bunch of experts, using expert interviews, if they could create the perfect package of energy policies for governments to do decarbonization, what would it be? And the top 4 policies in order at that time were, first and foremost, remove subsidies, especially for fossil fuels. Secondly, it was price electricity differently, more accurately, real-time prices, include externalities, things like carbon. It was do a feed-in tariff to incentivize renewables. And then finally, it was invest in a lot of energy efficiency, demand response. Those 4 things would get you roughly 70 to 80% of the way you would need to go, arguably, in terms of decarbonizing at least electricity.
And how far have we got?
Partially there. I don't want to...
I think we beg to differ. I'm not that optimistic. I think we really need some shock treatment of our policymakers before they actually take things seriously. And even Europe, every country is doing its own thing instead of working together and say, how do we roll this out and make it cheaper for everybody?
So, Alexandra, is that bringing us to your point that
Yeah.
I stopped you from saying earlier?
This is not such an easy thing to implement, but we did a study, I think last year, on Northern Europe and what is the optimal way, if you look away from democracy and countries, how much can you save by international cooperation on capacity markets and balancing? And the study showed that the investment needed by a systems approach can be 10% of the cost of doing it country by country. You can reduce the cost by 90% by having a European approach, which is quite phenomenal, but hard to achieve.
Is that credible, Volker?
He's looking skeptical.
Well, she just used the word system, so I thought EASA. Let's get an EASA response. He's not going to respond. He has to think. He has to put it through the model. Meantime, while Volker is thinking, we have a question from the audience, which is our friend from Mexico.
Again, at the beginning of this session, from this side, someone say, like, if it's so easy, why nobody make it before? So many times it's because no one have the idea before, or they are just keeping the idea. So I see that many of my friends just don't deliver an idea or a project because they think that this idea can be taken for a company or research or professor. So how can you protect your own idea or your own project and like in early stage when it's already like full and complete, like the one that we see, okay. But at the beginning, at the stage that nobody knows, how can you protect your idea?
Ellen Williams.
Okay. Well, I think that one answer to why, if it's so easy, why hasn't someone done it before, is that, in fact, it's not easy. Just having the idea is a great starting point, but there's a huge amount of hard work that you need to do to get beyond that point. So to protect your idea in the early stage, of course, you need to do patents and to be careful about who you share your idea with, but you can't be so protective of your idea that you can't communicate it to people and get out and demonstrate it. So absolutely, if someone has a brilliant idea, has to communicate it and convince other people to support them in moving that development forward to the point in which you can actually demonstrate to someone that they're going to be willing to invest in it. So an idea that's tucked away in the back of your brain because you're so afraid that that somebody might steal it, it might as well not exist.
Thank you. Knut.
Yeah, I think from my own experience, is very much about speed and less about protecting your idea. Because it's a market out there, you need to sell the product, you need to demonstrate, as you said, well, the businesses we have been into, we have very little focus on protecting the idea. And so far, it's from my point of view, it's of course you have to do parts of it. The IPR, you need to do parts of it, but the focus should be to sell it, to develop it, to get it out in the market. That is, and I have the maximum speed in that context. That is what I have seen from my experience when I develop companies.
Believe it? Yes, 2 thumbs up. Final question from Frida from NTNU.
All right. It's a bit of a follow-up kind of on the former questions here on the technology. And I agree with Ellen that we don't necessarily have all the technology that we need. But another question that I think is also equally important is that, especially looking at the battery technology, which I know the best, is that making a lithium-ion battery, producing it, takes a lot of energy. There's a really large CO2 footprint from making producing a battery. So making that process more environmentally friendly, reducing the CO2 footprint by producing a battery or a solar cell or any other renewable energy, maybe is that somewhere that we can be much better? I don't know if anyone would like to comment on that.
I would like to
Battery
comment,
queen.
if I'm allowed.
Yes, please.
Yes, yes, I do think, and I think it's really in when having smart production technologies, using digitalization, robotics, automation in a much smarter way than done currently. There we can really compete with the Asians that actually do the solar cells and the batteries and whatnot of all these technologies. I think we have a lot by putting people together cross-sectorially in a much better way than we are doing now is the solution. We really have to do that. So I, as a battery person, needs to talk perhaps to you and find ways of looking at that. Or what I know what Northvolt, the Swedish company that will build a big factory in Skellefteå, will do is that they will try to think in the circular economy and control the production of some of their electrode materials and the recycling, both to have the critical raw materials available, but also to be able to, a better way, have an economy around the carbon dioxide emissions. I think you really have to think in every step in a smart, new way. And it's not only electricity, they need water. Elon Musk has made one mistake. He put a factory in Nevada, and there is no water there.
Maybe not the only mistake, but we will leave it at that. Panelists, thank you very much. It's been a long day, and we really, really appreciate that you've stuck with us and kept your energy and ideas flowing and given us a huge amount to think about and stay up tonight thinking about. So you won't be the only one, Aidan. Let's put our hands together to say a big thank you to our panelists.